Good day, everyone. Today I'm going to demonstrate simple experiments that explain the different laws of thermodynamics.
First, we have Zeeroth law of thermodynamics, also known as heat transfer, stops when objects reach the same temperature. So here is the material needed: a cup of hot water and a metal spoon. Here I placed a metal spoon inside a hot cup of water. At first the spoon feels colder than the hot water. After some time, the spoon becomes warm because the heat transfer from the hot water to the cooler spoon. Eventually both spoon and the water reach the same temperature. Once they are the same temperature, this situation solved thermal equilibrium, which is explained by the Zeeroth law of thermodynamics. Then let's proceed to the first law of thermodynamics, which also known as energy cannot be created nor destroyed, only transferred. So here are the materials needed. We have here a metal spoon, a lighter and a candle. Here I have candle. Before lighting it, the candle contains stored chemical energy in the wax.
When the candle burns, the chemical energy transferred into heat energy and light energy. As the spoon plays and becomes hot, we can observe that the energy I being transferred through heat. This experiment demonstrates the first law of thermodynamics because the energy from the candle is not destroyed. Instead, it changes from chemical energy into heat energy and light energy. Next, we have second law of thermodynamics, which also known as heat naturally flows from hotter objects to colder objects. Materials needed: in ice cubes and a bowl. First, we place the ice cubes on a bowl and leave them at room temperature. We will observe WHST happens after a few moments. As the time passes, we can see that the ice cubes begins to melt or slowly turns into water. This happens because the surroundings are warmer than the ice. Heat energy naturally moves from the warmer air to the colder ice, causing it to melt. According to the second law of thermodynamics, this process happens naturally and continuously until equilibrium reach. Lastly, we have third law of thermodynamics, which also known as the colder an object becomes, the slower particles move. Material need: we have cooking oil. We will observe how cold temperature affects particles in motion. At a room temperature, cooking oil flows easily because its particles move freely. When placed in a solid environment, the oil becomes thicker and flows more slowly. This happens because the particles lose energy and move slower at lower temperatures. According to the third law of thermodynamics, particles' motion becomes extremely minimal as temperature approaches absolute zero.